This CBSE flashcard video, which is part 3 of the chapter Matter in Our Surroundings, we will cover flashcard number 57 to 90. Flashcard number 1 to 56 were already covered in part 1 and part 2 of this chapter. In this part, we will cover the following topics: effect of pressure on change of state, case study of carbon dioxide, evaporation, condensation, heat absorption, units and measurements, summary of change of state. Now that we know the topics covered in this part, let us begin with the first flashcard and understood how pressure can change a gas into liquid. How does increasing pressure change gas to liquid? Applying pressure reduces the space between the particles of gas, bringing them closer and converting the gas into liquid. Example: liquefied petroleum gas is made by compressing petroleum gas. Now we will move to next slide. Which property of gas is utilized in LPG and CNG cylinders and how? Their highly compressible nature. This property allows the gas to liquefied under high pressure for storage and transport, as seen in LPG gas and cylinders. Next, how can gas be liquefied? A gas can be liquefied by cooling it below critical temperature and applying pressure. Remember, liquefaction needs two things: cooling and pressure. To understand cooling better, we must know one important term. What is the critical temperature of a gas? The critical temperature of a gas is the highest temperature at which it can be liquefied by applying pressure. Above the critical temperature, the gas cannot liquefied by pressure. Now let's apply these ideas to an important case study. How is carbon dioxide stored in cylinders? Carbon dioxide is liquefied under pressure and stored in cylinders. Let's see what happens when this pressure is suddenly released. What happens when carbon dioxide cylinder valve is open? High pressure liquid carbon dioxide comes out rapidly and cools, forming the solid carbon dioxide. This special behavior gives solid carbon dioxide its name. Why is solid carbon dioxide known as dry ice? Solid carbon dioxide is called dry ice because at atmospheric pressure it undergoes sublimation. It changes directly from solid to a gas without passing through a liquid phase. Since it produces no liquid, it leaves no wetness and hence name dry ice. Solid to gas directly is called sublimation. Let's move to evaporation. What is evaporation? Evaporation is a process by which molecules at the surface of liquid changes into vapor at any temperature below its boiling point. Example: clothes drying on a line. To avoid the confusion, let's compare evaporation with boiling. How is evaporation different from boiling? Boiling occurs at fixed temperature and throughout the liquid. Evaporation occurs at all temperature at only surface. Boiling is fast and fixed. Evaporation is slow and continuous. Next, why does evaporation occur? Particles of the matter are always moving. In liquid, some particles at the surface have enough kinetic energy to break away from the force of attraction and become vapor. Remember, fast-moving particles escape from the surface. Let's now learn the factors that affect evaporation. This is the four factors that increase the rate of evaporation. Increase in surface area, example: spreading clothes out to dry. Increase in temperature, example: clothes dry faster on a hot day. Decrease in humidity, example: clothes dry slowly on a humid day. Increase in wind speed, clothes dry faster on a windy day. You can remember this like STHW: surface area, temperature, humidity and wind speed. First, let's see the effect of surface area. How does the surface area affect evaporation? Give an example. Evaporation is a surface phenomenon. Increasing the surface area increase the rate. Example: we spread clothes out to dry them faster. More surface area means faster evaporation. Next, how does the temperature affect evaporation? With increase in temperature, more particles get enough kinetic energy to go out into the vapor state. Example: clothes dry faster on a hot summer day. Now let's understand the role of humidity. What is humidity? How does it affect evaporation? Humidity is amount of water vapor present in air. If humidity is high, the air already holds a lot of vapor, so the rate of evaporation decreases. Example, clothes takes longer to dry on a humid day. Remember, high humidity slows down the evaporation. How does wind speed affect evaporation? With increased wind speed, water vapor particles move away, decrease the amount of vapor in surrounding, which increases the rate of evaporation. Example, clothes dry faster on a windy day. Next. Why is tea or milk cool faster in saucer than in a cup? A saucer has large surface area, so evaporation is faster, leading to quicker cooling. Next. Why do desert cooler cool better on hot dry day than on a humid day? On hot dry day, evaporation is faster due to low humidity, so cooling is better. Let's go to next slide. How does evaporation cause cooling? During evaporation, the higher energy particles escape from the liquid. The remaining particles have lower average kinetic energy, meaning the liquid temperature decreases. This loss of energy from liquid and its surrounding results in a cooling effect. Remember, high energy particle escapes, so temperature falls. This effect can be felt directly on our skin. Why does our palm feel cold when we put acetone or perfume on it? Acetone and perfume are volatile liquids. When we put on our palm, they absorb energy from the skin to change state. This energy is used as latent heat of vaporization. The rapid loss of heat from our palm causes the cooling sensation. Remember, evaporation takes heat from our skin. Let's explain this cooling effect in another way. Why do people sprinkle water on a hot roof? People sprinkle water on a hot roof because water absorbs a large amount of heat from the roof during the evaporation due to its high latent heat of vaporization, thereby cooling the hot surface. Now let's see the next flashcard. Why should we wear cotton clothes in summer? Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to atmosphere for evaporation. During evaporation, heat energy equals to the latent heat of vaporization is absorbed from the body, leaving the body cool. Let's move to another example. Why are water-filled earthen pots, matkas, used in summer? Water seeps out through the pores of pot and evaporates, absorbing heat from the surrounding and cooling the water inside. Now let's see the opposite of evaporation. Why do water droplets form on a glass of ice-cold water? The water vapor present in air comes in contact with cold glass, loses energy and get converted into liquid state. This process is known as condensation. Now we will move to next slide. Why do we prefer wearing dark color clothes in winter? Dark color clothes absorb more heat and keep us warmer. Before ending, let's revise some important units. What is SI unit of mass? The SI unit of mass is kilogram. Mass is measured in kilogram. Let's continue. What is the SI unit of volume? The SI unit of volume is cubic meter, written as meter cube. The commonly used unit of volume is liter, written as L. 1 liter is equal to 1 cubic decimeter. 1 liter is equal to 1000 milliliter and 1 milliliter is equal to 1 cubic centimeter. Remember, SI unit is cubic meter, common unit is liter. Let's move ahead. What is SI unit of temperature? SI unit of temperature is Kelvin. Let's learn how to convert temperature. How can Celsius temperature be converted into Kelvin? By adding 273 to the Celsius temperature. Next. How can Kelvin temperature be converted into Celsius? By subtracting 273 from the Kelvin temperature. What is SI unit of pressure? SI unit of pressure is Pascal. 1 atmospheric pressure is equal to 1.01 into 10 to the power 5 Pascal. Next. Summarize the effect of change of state with heating. Solid into liquid is called melting. Liquid into gas is called vaporization. And solid into gas is called sublimation. And finally, the change of state with cooling. Summarize the effect of change of state with cooling. Gas into liquid is called condensation. Liquid into solid is called freezing. Gas into solid is called deposition. Remember, condensation, freezing and deposition occur on cooling. With this, we complete the revision of change of state. Up to flashcard 89, we have covered all important and possible questions and answers from the chapter text. In part 4, we will cover the question given within the chapter text along with the exercise question at the end of the chapter. With this, we complete part 3 of chapter Matter in Our Surrounding. Thank you for watching this video. If you like this video, please subscribe to the channel so that you don't miss any part of this chapter.